current slide. Maybe. There we go. Now, as far as I know, they came out, published a final exam schedule, and when I looked at it, I saw there was a couple of mistakes on it. One that seemed pretty major. The most of it's correct. One thing, they said final exams start not this coming Monday, but the following Monday, according to the academic calendar, the administrative calendar, every other calendar I've seen. Finals start on Tuesday and go through the following Monday. Okay. I don't know why they put the final exam schedule wrong. I emailed them and told them. Haven't heard anything back. So, I was talking to the dean yesterday, and I forgot to ask her about it. But, anyway, our final is a week from this coming Tuesday. Okay? And we'll talk about that in a little bit. Okay. Let's see. Are any of you graduating this term? You are. Okay. It's most important that you get everything into me as soon as you can, because your grades are due in by noon on Friday of finals week. So with the exam on Tuesday, shouldn't be an issue. But if you do miss the exam, get it made up soon, because I have to have your grades in by noon on Friday. The rest of you is noon the following Wednesday. And that was another error they had. They had that they were due Monday the 8th, which Monday was the 6th. So that was double duty wrong. TK, right? Okay. All right. So I think that, and then later in the same document they had it Wednesday the 8th. So that was just a misprint there. Okay. Can't think of any other major announcements. Let's talk about this class. We're almost through with 2.6. We'll finish it most quickly today, and then we'll move into chapter 3. Okay? No, we're not going to get a lot done in 3, but we'll get started, at least get you exposed to exponential and logarithmic functions. Okay? Now, the test, since we'll finish chapter 2 today, the test for chapter 2 will be Tuesday. Okay? It will not be as long as the test for chapter 1. That was a bit long. Okay, so this one will be a bit shorter. I think only 1 page. And y'all seem to be picking up on the material pretty well, those that are here, which are you guys. So I think you'll find that pretty good. Now, that leaves us with today in chapter 3 and then next Thursday in chapter 3. However, the other thing I'm doing next Thursday is returning all your work to you. So if you don't have a test finished or started, that's a 0, because I got to return the papers to you so you'll have them in hand before the final exam. Okay, so please, if you haven't turned in a quiz, if you haven't finished a test, and many of you haven't, not that many, but a few. And then the other thing is your research papers. Folks, still more than half the class hasn't turned in a research paper. And this is your last weekend coming up before it's due. Due last date before you start losing points is next Thursday, a week from today. So please get your research papers in sooner rather than later. Okay? Quiz 1, most of you have turned this in. I see 1, 2, 3, 4, 5, 6 that haven't. Now, some of those may have withdrawn. So those 6 haven't done test 1, and there are a few others of you. If you don't see a grade on Blackboard, that means I didn't know if you were finished with your test or not. So check with me. If you haven't even started your test, that's the other reason you're no grade on Blackboard. Okay? Quiz 2, got 1 in today, and I'd say barely half have turned in quiz 2. You've got to turn in quiz 2 before you can take test 2, which is Tuesday. Okay, so please get your quiz 2 in before. It'd be nice to turn it in today so I can get it graded over the weekend and you can see what you missed before you take the test on Tuesday. But it's not looking likely for a lot of people. Okay. I'm sorry? And 3. Yeah. Yeah. Okay. So, let's talk then about the final exam. The first part of the final will be not the final, but a very short test on what we covered in Chapter 3. Okay? Very short. 1 page, but not many questions. Several places you can earn points, but not many questions. Okay? Then the final exam, again, will be pretty short. 1 page, and something you can finish pretty easily. So you'll have a full hour to work, 50 minutes to work on the first one, the Chapter 3 test. You won't take that long. And then the final, you'll have an hour, and it won't take you that long. If you finish the one, you can start the other. You'll be out of here pretty soon, 2 weeks from Tuesday, a week from this coming Tuesday. All right, any questions? Yes. On the 30th, yeah, Tuesday the 30th, right. Last day of April, which seems awfully early for starting final exams, but that's what they have on the calendar. They actually, say again?
Chapter 3 about final exam.
Yeah, there won't be many, if any, questions on Chapter 3 because you'll have the test right before that, so that'll be your coverage on Chapter 3. I think the final will be mostly 1 and 2. About 5 questions on 1, 5 questions on 2. And that's why I want to get you back your papers next Thursday so you can have those to look at. I'd love to give, and in fact, that includes the second test. So if you don't do the second test on Tuesday, that's all she wrote, folks, because I'm turning them back on Thursday so y'all can have them to study. So hopefully everybody will be here to take the test on Tuesday. Yeah. Now, if I get any more of it, if I get all those quizzes in before then, you're going to have the quizzes earlier. The only reason I haven't given anything back is still people haven't turned it all in. Now, remember, a research paper I can't give back because they periodically ask for samples of student writing, so I have to hang on to those. But your quizzes and tests, you will get back. Final exams, you don't get back. I'm required to hold on to those for 3 years. I don't know why, but I am. Okay. So research papers and finals, I hang on to for 3 years. All right. Any questions? Tomorrow, I'm on the Birmingham West Campus from 8 to 12. As far as I know, we don't have any meeting schedule. I sure hope not this close to finals. Oh, and here's the other thing. If I meant to say this while Q was still here, but she had to leave. I'm a little behind on grading, not seriously, but somewhat behind on grading, and definitely behind on getting grades on Blackboard. The main reason for that is we're doing fall schedules now, and fall schedule is a terrible mess. We tried something new last fall, and it was awful the way we did it. It was awkward. Everything messed with it. They've changed it starting this spring, so now we have to change everything for fall schedule. So I'm still working. I've been working on that. I will be working on it tomorrow during office hours, but you're welcome to come in. Now, if you are going to come by and need to do something during office hours, and you need me to have it, like a quiz or a test, let me know today because I'll be over there, and if you haven't let me know you're coming, it'll be over here. We'll be over there. So if you are going to work on something, yeah. Say that one more time. Okay. I heard something about too awful.
When you compare the fall system that was awful.
First fall system that was awful.
No. It was a mess last fall. A terrible mess last fall. Yeah.
Okay, so if we're completely going to schedule on everything, can you go ahead and share us with that so we can start working on it?
You see,
No.
people who haven't turned something in may lay eyes on yours, and the correct answers are on yours, and then they'll cheapen your grade because they'll have inside information that you didn't have because I've put the correct answers on the papers I corrected. All right, let me get the people who just came in. Saw Samaya. I can get across the page to you. And I saw Thomas. No, yeah, right? Yeah, okay. All right. This is an obnoxious pen. Okay. Anyone else come in since I called roll? Okay.
And what room are you going to be in?
Birmingham campus?
Do you know where Dr. Pruitt's office is? No. Okay. It's B122. B is the academic building. Okay. Right. And Birmingham West Campus. There's a quad of 4 buildings in the center of a big, sort of like a circle. Yeah. Academic building. And we're on the end toward the baseball field, the gym, the tennis courts, those kinds of things. On that end of the building, and when you go in the B building from either end, you either go down half a flight or up half a flight. Go up half a flight. And when you get to that top step, if you come in from the gym side, the tennis court, and the baseball side, if you come up that on the top step, the door's right there on your right. If you come in the other side, come all the way down the B hall, and it's the last door on the left before you fall down the stairs. Okay. Okay, good deal. All right, let's get going with any other questions before we start 2.6. Okay. Not start 2.6, continue 2.6. All right. Did you have one? Oh, okay. We're doing example 5, and I'm pretty sure example 5 is not on the PowerPoint. So that's why we're starting here, and I can't get my pen to work. There we go. Okay. Example 5. Sketch the graph of f of x is equal to x over, and here's Krista. All right. Anyone else come in since the call off? X over x squared minus x minus 2. It says sketch the graph. Where and how would you start this process? Factor everything in sight. The numerator is already factored. That's a prime representation. But the denominator, if it's factorable, how would it factor? Help me. X times x. Very good. Say again. Okay, the 1 and 2, I agree with that. And what? Minus and plus? Plus and minus. Okay, very good. Y'all are good at factoring. Okay, let's check it. X times x is x squared. Good. Minus 2x minus x, or plus x would be minus x. Perfect. And then minus 2. Yes. That's what we've got for factoring. All right. Okay, she's going to go with that denominator, set them equal to 0, and what would that produce? Because guess what? The denominator cannot equal 0. Okay? So if either of those are 0, the whole denominator is 0. So we say x cannot equal -1, or x cannot equal 2. Okay? Now, we have, what would these produce then? If x can't be that, what do these produce? Vertical asymptotes. Okay? Now, you don't have any that are going to be open things because the numerator didn't factor. Okay? There's no common factors. So both of these are vertical asymptotes. So we can start our graph that way. Let's do the graph here. And we'll do 1, 2, 3, 4, 5, -1, 2, 3, 4, 5, net positive 1, 2, 3, 4, 5, and -1, 2, 3. Okay. Now, x not equal -1. Let me get my red pen up. Oh, I love using that red pen, don't I? No, I'm just kidding. Okay. Okay. X cannot equal -1, and x cannot equal 2. So there's your 2 vertical asymptotes. And all right, there we go. What else do we do? Got the vertical asymptotes. Let me get my, okay, wait just a second. Let me get, vertical asymptotes are these 2. Somewhere I heard horizontal asymptotes. What did you say about them? Yeah, it's the ratio of the leading terms. And what does that give you? Say again? X will go into x squared x times. It leaves you 1 over x. What happens to that when x gets very large? 1 over x. He's sneaking out on me. Okay. Where is that? What's happening to the function value? As 1 over x, when x is very, very large. 1 over 10 million. What's that real close to? 0. 1 over 2 is close to 0. 1 over 3 is even closer. 1 over 4 is even closer. 1 over 5. How are you getting the denominator? The closer you're getting to 0. So your horizontal asymptote is y is equal to 0. So let me get my red pen back. And that will be the x-axis. Okay, there we go. Now let me get my black pen back. What else do we need? We got vertical asymptotes, horizontal asymptotes. Say again? The what? Okay, x-intercept first. What's true about the x-intercept? Y is equal to 0. Where do you see a y on the board? F of x. And for that to be 0, what would have to be 0 over here on the left-hand side? Right-hand side. The x would have to be 0. So 0, 0 is your x-intercept. 0, 0. So there it is. Now that touches the horizontal asymptote. Perfectly fine. You can touch or cross a horizontal asymptote. You can't touch or cross a vertical asymptote. And H is here. All right. Did anyone else come in since the call roll? All right. Now, he's sneaking back. Okay. We got x-intercepts. That's where y is equal to 0. Any guesses on y-intercepts? What? 0 also. That is also your y-intercept as well. And it's the only intercept you have. So that doesn't tell you a lot, except that's the only point we know. So we're going to have to do some test points. What would be your suggestions for test points?
Okay, it has to be approaching number, so infinity, whatever number.
Okay. Get something to the left of the first asymptote, so we'll choose -2. Okay, there's an intercept. We need something between the first asymptote and that. That's going to be -0.5, I would suggest. Something between this point and that one, and that would be +1, and then something to the right, and that would be 3. Okay, so those are our 4 test points. Let's see what they produce. Now let's see, will we be better off using factored form or regular? It doesn't really matter. Let's do f of, which one do you want to do first? 1. Okay, f of 1. Okay, if we use the factored form, that would be 1 in the numerator. That was easy. Divided by 1 plus 1 is 2. All right, we got high level math today. 2 times, and 1 minus 2 is 1 minus 2, -1. So you have 1 over a -2, which is -1/2. So at 1, you're at -1/2. Right there you are, folks. Okay? We know where you're heading here. You got to be heading toward the vertical asymptote. No choice. There's not another x-intercept here, so it can't come back up, so it has to be going down. Okay? What you want to try next? Got 3 other points, test points. We got that one done. Help me, somebody. Make a decision. Say again? -1/2. He loves his fractions, okay? F of -1/2. Okay, we know the numerator is going to be -1/2. The denominator, -1/2 plus 1 is -1/2 plus 1. Anybody? Not that hard. 1/2, okay? And on the second one, -1/2 minus 2. -1/2 minus 2. minus 5/2. Minus 2.5. That's minus 5/2. Okay. And here's Kadarius. All right, good deal. Anyone else come in? So, yes.
How did you get 2 in the first one? F of 1?
Okay, this one?
No, F of 1.
F of 1.
Yeah, how did you get 2?
2, okay. 1 plus 1. Is,
Oh, I was looking up.
what's that?
And
Okay. And then the other one was.
so you don't have to do with the original term.
Yeah, you could have used this form or the factor form, either one.
Oh.
To me, this was easier, so I did that way. Okay. Now, let's play around with that denominator a little bit. This will be a negative 1/2. Okay, in your numerator. The denominator is a negative 5/4. Everybody see that? Okay. Now, first thing I notice, negative divided by negative is going to be positive. And I'm going to take that denominator, invert, and multiply, meaning multiply by 4/5. Right? Rather than dividing by 5/4. And 2 will go into 4 twice. So I get 2/5 for my y value. Well, it's positive, and we know it can't go back down, or otherwise we'd have another x-intercept. So it has to be going up. So it goes up from here and approaches, whoop, it doesn't cross, it approaches the y-intercept. All right, so we got those 2 done. 2 more test points. Which one you going to go for next? 3. Okay, we'll do the 3 over here. So f of 3 will be 3 over 3 plus 1 is 4 times 3 minus 2 is 1. So 3/4. Okay, for 3 over here, we're going to be at 3/4, somewhere right about there. Okay, we know where that's going. You can't go back down because you have another x-intercept. We don't have one, so it's got to be going up, approaching the vertical asymptote. And this, as you get larger and larger, you're going to approach the horizontal asymptote. So there we got that one done. One more. No, not minus 1. Minus 1 is minus 2. So f of minus 2 is equal to, numerator, of course, is minus 2. Denominator is minus 2 plus 1 is minus 1. And the other one is minus 2 minus 2 is minus 4. So that gives us, second? No, you get negative 2 over positive 4 is negative 1/2. Watch those signs. They'll reach out and trip you every chance they can. Okay? They're mean that way. I'm not talking about Hamina. I'm talking about the minus signs. Okay. All right. Anyone else come in since the called roll? You didn't hear me acknowledge your presence. Okay. All right. So we got, what did we wind up with there? I've lost it now. Is it negative 1/2? I believe that was it, wasn't it? So down here at 3, we're negative 1/2. So somewhere about right there. So we know where that's going as we approach vertical asymptote here, horizontal asymptote there. There we have it. That should be the graph of our function. Looking in the book, theirs isn't quite as pretty as mine, but it's close. Okay. Make sense? Had to do 4 test points that time because you didn't know which way it was heading. So you have to do every interval that's either between a vertical asymptote, which is x equals something, or an x-intercept, which is x equals something. So you have to do one outside, between, and outside. Okay. Good deal. Any questions? There is a checkpoint. I highly recommend you do the checkpoints. All right. I'm going to clear this. Hope everybody had it. I should have asked first. Okay. And let's do example 6. Sketch the graph of f of x is equal to x squared minus 9 over x squared minus 2x minus 3. I wish I'd have left more room at the top. Okay? What are you going to do first? There's several things you can do. What would you like to do? Factor. Let's factor everything in sight. That numerator factors as x plus 3 times x minus 3. Denominator factors as, if it factors, first terms will be x and x. Signs will be plus and minus. What will the numbers be? Okay, in which order? The negative, so minus 3 plus 1. Perfect. Check it and see. X times x is x squared. Minus 3x plus x is minus 2x. And then minus 3. Yes, yes, yes. And what do you notice here? X minus 3 in common, so they divide out. But that doesn't mean that you can put a value in for x equal 3. X still cannot be 3 because that would make your denominator 0. So we know that x is not equal to 3, but that will not be a vertical asymptote. However, this one, since it doesn't factor out, will be a vertical asymptote. What would that produce? X cannot equal negative 1. That's your vertical asymptote. This is your hole in the graph. Okay? HNG, hole in graph. Okay. I just made that up. Okay. So we've already got a vertical asymptote. What else could we do? What else could we do? Say again? Horizontal asymptote. Let's go for that. What would be your horizontal asymptote? Say again? 1. You're absolutely right. Ratio of leading terms, x squared over x squared is 1. So it's y is equal to 1. Okay? Good. Next. Second. Not yet. You can. I mean, if you wanted to work real hard, but, be lazy. Get all the information you can. What else can we get? Relatively easy. The easiest thing to get, folks. Which one? X-intercept is not bad. What is true about the x-intercept? Y is equal to 0. Well, y is equal to 0 at 2 places. Either where that numerator is 0. X squared minus 9 is equal to 0. That's the only way that y can be 0. Well, that would be x equal minus 3 or x equal plus 3, but x can't equal plus 3 because it's in the denominator too. So your only x-intercept is going to be x equals minus 3, and then you know the y value there, right? 0. Perfect. All right, you got 3 out of 4. What are we missing? Y-intercept, the easiest one, folks. How do you get y-intercept? Yeah, plug in what? Where? X is equal to 0. So all these disappear, and what are you left with? Which is? 3. Y is equal to 3. So x equals 0, y is equal to 3. So 0, 3. There's your y-intercept. Now we're ready to plot, okay? And scheme and do all sorts of things like that, okay? There's 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, 5. I don't know why I'm sucking 5s today, but it's good. Let's plot what we know. Vertical asymptote. Vertical asymptote. Y can't equal, x can't equal negative 1. And for some reason it's not there. It's slow, but it's coming. Okay, I'm slow too. Hey, not that funny. Okay. Horizontal asymptote. y is equal to 1. That's the horizontal line here at y is equal to 1. There we go. Get out of there. Okay. Now, got a couple intercepts. What are they? Negative 3, 0. That would be right about there. Whoops, let me get my pen back. Okay, right about there. And the other one is 0, 3. That's right about there. Hey, we don't need any test points, do we? Because we know this one has to be going toward the horizontal asymptote and has to be going to the vertical asymptote. Okay? And we know this one has to be going to the vertical asymptote and toward the horizontal asymptote. Done. No test points required. Yes?
What's it true about the x-intercept?
What about the x-intercept?
You told something, right?
What?
You told something about x-intercept.
The x-intercept is where y is equal to 0. In a rational expression, the only way you can get this to be 0 is for the numerator to be 0. The numerator factors as x plus 3 times x minus 3. Well, x equal minus 3 makes that 0, and that's a good one. X equal plus 3 makes it 0 too, but you can't have x equal 3 because of what we found earlier. It's also in the, oh, and that reminds me, y'all let me get away with it, didn't you? Shame, shame, shame. At x equal 3, it can't be 3. So at x equal 3, we have to put a hole in the graph. You left off your hole in the graph. I had it right there, HIG. Second? Okay.
So how are you telling how many test points that you should use, that you should try?
Okay.
Like I know in this one we didn't have any.
Well, what you need to know what's happening here and here. Well, you got a point there from the x-intercept, and you got a point here from the y-intercept. That's all you need. Now, if, like that last one, we only had one here, and we didn't have any here, so we didn't know if it went up or down, okay? And it went both directions, we didn't know where. And we didn't have one there or there, so we needed all the test points there.
Oh, okay.
Yeah. The book would say, put one out here, and one somewhere over here, okay? You don't need them. This tells you what's happening in this quadrant, this and this quadrant. You need to know what's going on in every interval. And you know. You really only have two intervals here because this can't come back down, so it has to approach the horizontal asymptote. This can't come back up because it has to approach the vertical asymptote. Okay? And this one can't come back down because it would be another intercept we don't have, so it has to approach the vertical asymptote. This one would approach the horizontal asymptote with our hole in the graph at x not equal 3. Make sense? Good deal, folks. There is a checkpoint. Please do the checkpoints. All right. If no questions, I'm going to move on, okay? All right. Now, did I get everyone who came in? No. Tara came in. I knew that somebody snuck in on me while I was talking. So here's Tara right there. Anybody else come in? Okay, that I did not acknowledge. Okay. So let's move on to, that was all example 3. We've already done that. Slant asymptotes. I'm going to give you a slideshow on this. I'm not going to require anything of you on this. Okay? So we're basically almost through. Let's just do the slideshow though. Now, we have vertical asymptotes. Those are there. You can't avoid them. Sometimes you have horizontal asymptotes. Sometimes you don't. Sometimes they're 0. Sometimes they're not 0. Sometimes they don't exist at all. There is a case when there's no horizontal asymptote that you might have what they call a slant or an oblique asymptote. And here's when that happens. When the numerator has degree 1 greater than the denominator. When the numerator is greater than the denominator in degree, you have no horizontal asymptote because you always wind up with a x or x squared or x cubed or x something in the numerator when you do the ratio of leading terms. And when that goes to infinity, it's blowing up. Right? So no horizontal asymptote. But when this is exactly 1 degree more than the denominator, that means if you did your synthetic division, you would get a linear answer because x would go into x squared x times. Okay? So that has a slant asymptote. See, it is going to infinity, positive infinity here, negative infinity there. So it has no horizontal asymptote, but it's going along this line right here. How did they get the line? They divided this into that. And you could actually do synthetic division on that one. -1 on the outside, blah, 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 going from there. And you'll find you have y is equal to, when you do that division, x minus 2, then with the remainder. Okay? Forget about the remainder. The x minus 2 gives you the slant asymptote. Okay? This will not work if this is 2 more than that. Only if it's 1 more. All right. Yeah, all right. No, I'm sorry. Sorry. Say again? Alana, got it. There you are. Okay, I knew you were in here somewhere. All right. Get this. Okay, anyone else come in since the called roll? Okay, again, you're not responsible for this on the test, but just so you'll know in the future, if you ever have a situation like this, rational expression, the numerator is exactly 1 degree greater than the denominator. Why did that come on? I don't know. Okay, then you can divide that into it. Whatever your linear part is, that's your slant asymptote. Whatever your remainder is, just forget about. And you can draw that line in there, and then you know it's going to put the vertical asymptote there and the horizontal asymptote there. So that you have to do a test point here and here to see where actually your I guess touching the board does that, doesn't it? No, it didn't. Okay. So anyway, your horizontal asymptotes would have told you x equals 0, x equal to 1. Yeah, those are those two. You knew you'd have to be here for that part, and that almost guarantees you're going to be there for that part, but you could do a test point in -2 and find out you are there. Okay, we're not doing these, so don't sweat them. So to find the equation of the slant asymptote, use division. If you can do synthetic division, fine. If not, long division. They did long division, dividing that into that. They didn't show you, but they did. You could have done synthetic division, gotten the same answer. You get x minus 2. That part gives you the equation of the line. Y-intercept of -2, slope of 1. Okay? Don't worry about this. That just is where it's going as you get closer and closer. Okay, so that's how you do slant or oblique asymptotes. Okay, will this have 1 or not? Yeah, because the numerator is 1 more than the degree. And frankly, now, I was going to say, it looks like you could almost factor, you can factor, but this will be x plus 1 times x minus 2, so nothing will go out. So you have a vertical asymptote where? Vertical asymptote?
Oh,
plus 1. You have x-intercepts at -1 and +2. Remember I factored that. And you have the y-intercept of at 2. Okay, positive 2. Okay, so you already know 3 points. You know a vertical asymptote, and all you have to do is do your division. And you can actually do that division synthetically. Put 1 on the outside and a 1 minus 1 minus 2 on the inside. Go to town, see what it gives you. I'll let them go to town and tell you what they got. Factoring the numerator gives you the x-intercepts. We said that. Okay, long division or synthetic division will give you x is the linear part. And that's all, just x, not x plus or minus anything else, just x. If you do the division and show, you get a 0 for the center term. So we don't mess with that. So that will then be that's the identity function going through the origin, splitting up the diagonal there. That's your slant asymptote. Okay? And then you got 3 points you can plot. Y-intercept is 0, 2, which you just told me. X-intercepts were -1, 0, and 2, 0. Vertical asymptote, y is x equal 1, okay? And slant asymptote, y is equal to x. You plot all, you don't need any more, so plot those here. Vertical asymptote here, x-intercept's there, and your y-intercept there, and slant asymptote there, goes through the origin, slope of 1. You got it? If you got 1 point here, you don't need that and that. You know it's got to place the vertical asymptote this way, the slant asymptote this way. You got 2 points over here. You don't need 2 more points. All you have to do is go for the slant asymptote here, vertical asymptote there. Okay? You don't need to do this. We're not doing it, but that's how it works. Just as easy as before. Only difference is this right here we give you no horizontal asymptote, but because that's exactly 1 more than that, you do get a slant asymptote or oblique asymptote. Now, applications. Many examples of asymptotic behavior in real life. For instance, here's example 8 coming up, shows how a vertical asymptote can help you analyze the cost of removing pollutants from smokestack emissions. Okay? Utility company burns coal, shame, okay? Not much anymore, to generate electricity. The cost C in dollars. Now, if anyone works for the coal companies, I don't mean you might, disparage you or anything, but it's going out, folks, okay? Because the renewables are getting cheaper and cheaper, and coal is dirtier and dirtier. Okay, okay. The cost C in dollars of removing P%, okay, cost C in dollars moving P% of smokestack pollutants is given by this thing. C is equal to 80,000 P divided by 100 minus P, okay, where P goes anywhere from 0 to 100. You either remove none of it or you remove all of it. If you remove none of it, the cost is 0, because 0 times 80,000 is 0. If you remove half of it, that'll be 40,000 divided by 50, which is a pretty small amount, okay? But then as you keep increasing, the larger percent you're removing, this gets bigger, this gets smaller. And when you get a big number divided by a small number, the number gets huge, okay? So you're a member of the state legislature, a whole transfer. I'm not notified, okay? You are a member of the state legislature considering a law that would require utility companies to remove 90% of the pollutants from their smokestack emissions. The current law requires 85% removal. How much additional cost would the utility company incur as a result of the new law? Okay? Well, all you have to do is plug it in, plug it in. There's not really a lot to do here, okay? You do, for 90%, that would be 80,000 times 90 divided by 100 minus 90, okay? 80,000 times 90 is 720,000. 720,000 divided by 10. So wipe out a 0 here, and that would be $72,000. That would be the cost of removing 90%. How does that compare to the 80%? 85% of its current? You'll have to do this on your calculators. I'm not about to do it in my head. I could, but I don't want to. 80,000 times 85, that is doable, divided by, I'll do that one, 15. 100 minus 85 is 15. So your numerator's gotten smaller, your denominator got bigger, so the amount will be less. Someone do that quickly. That would be 400,000 plus 40, goodness gracious. So that'd be 60, huh? What you get? A little louder? Huh? Okay, is that divided by 15 or not? Okay, say it one more time. 453 what? And 3 zeros? Oh, 333. Okay, where's your decimal? Do you have a decimal? Now, either I did something wrong or something's wrong there. Huh? At the end. Right here. But at the end. Well, either I did something wrong or in mine, or this is not quite correct here. Let me see what the book got. Okay, neither one of them are right. Oh, wait, no, you're right. Okay, I did mine wrong. I have an extra 0. Sorry. Okay. So, evidently this was 7 million here. I didn't do it right. Okay. Let's see how I messed that up. Oh, yeah, I didn't count one of those zeros. Yeah, sorry. There should be 5 zeros, and I only had 4. Yeah. So it was 720,000 the old way. I know, the new way, and 453,000 and change the new way. So the difference would be, subtract those two, and they do it in the book, $266,667 more to do the extra 5%. Okay? That is why, folks, coal is losing ground, because it costs so much to clean it up, whereas natural gas doesn't produce it in the first place. And renewables produce nothing in the first place. So that's why coal is basically on its way out, at least in the U.S. and many other industrialized countries. Third world countries are still using it like crazy, but they're even cutting back. So the other bad news is that most of the cleaner coal, if there is a cleaner coal, it's already been used up. And the coal we're getting now is dirtier and dirtier, so it costs even more and more to clean it up. Whereas natural gas, which we're producing so much of nowadays, is so much cleaner. So it's not political, it's reality. It's dollars and cents. Okay. So, if you did the cost of the current, that gave you $453,333 like you got. And to remove 90% was $720,000. So the difference being $266,000. More than half of what it currently costs to get 85%. So, wow. It's a lot more expensive. And folks, the coal company says that's why you shouldn't put it on the additional restriction, where everybody else says, no, that's why you should put the restriction on, because it's just not worth it. Okay. It's so expensive to clean it up. All right, and that was the last example. There is a checkpoint at the bottom, and you certainly are welcome to look at that. Oh, wait, there was one on number 9, so let's do 9. Okay, we either got that much white space or that much. Let's do that. Okay. Number 9, finding a minimum area. A rectangular page contains 48 square inches of print. They're drawing it landscape, so I will draw it landscape as well. Okay? 48 square inches of print. You're printed in here. Okay? This is 48 square inches, if I'm reading the problem right. The margins at the top and bottom are each 1 inch deep. It's coming back. Okay. Each 1 inch deep, so you got 1 inch here, 1 inch here. Mine's not drawn to scale, by the way. 1 inch here, and 1 inch here. 1 inch here. That was one. Never mind. Okay. Wait. I'm sorry, I misread it. Top and bottom are 1 inch. On the sides, it's 1.5 inch. Sorry, I need to read the problem better. This is 1.5 inch on the sides. Okay? What should the dimensions of the page be to use the least amount of paper? Okay. What should the dimensions of the page be to use the least amount of paper? Okay? Well, dimensions of the page will be length times width, right? Now, They don't give us any, oh yes, they do. And they give us that the rectangular page contains 48 square inches of print. Now what I can't figure out, is that the gray part in the middle, or is that the total page? I think it's the gray part in the middle, isn't it? Yes, inside the margin. Okay. So what they're calling this is X this way and Y that way. So we know that X times Y is equal to 48. Right? They told us that. We also know that the length of the page is going to be your X plus 3, right? Because you've got 1.5 inches here and 1.5 inches there. So you got the length of the page is going to be X plus 3, and the width of the page is going to be width is equal to Y plus 2, right? That's the width of the page. All right. Now, what should the dimensions of the page be to use the least amount of paper? Okay? What we need to do is to determine the area of the paper. Okay? The area of the paper is going to be length times width, X plus 3 times Y plus 2. Okay. Now back up a minute. We don't need two variables. We want only one. If you want to use, you'll use this that we know and either write, why don't we write Y is equal to 48 divided by X. You okay with that? Okay. So instead of Y here, then we'll do X plus 3 times 48 over X plus 2. Okay? Now, that's going to be our dimensions. Now, we also know X has got to be a positive number. X and Y both have to be positive numbers. L and W have to be positive numbers. You don't have any negatives. So they just noted that, which is sort of, should be pretty obvious. Okay. So what we're going to do here is, I was going to say, how in the world are they going to do this without calculus? They're using a graphing calculator is how they're going to do it. And so that's why I skipped it last time. I wondered, why did I skip this before? That's why. The only way you can do that with the tools we have in our belt now is with a graphing calculator. And that's what they did. And since they don't show it on the slide, if you got your book, look at it, and that gives it to you. There's no way other than calculus to do this otherwise. And I kept thinking, they haven't given us enough information here, and sure enough, they haven't. So that's it. Let's do the vocabulary at 2.6. Functions of the form f of x equal n of x divided by d of x, where n of x and d of x are both polynomials, and d of x is not the zero polynomial, are called blank blanks. Look at the title. Rational functions, perfect. Number 2. When f of x is approaching plus or minus infinity, as x approaches a from the left or the right, x equal a is a blank blank of the graph of f. So when the function is going to either plus or minus infinity, as x is approaching a from either left or right, what is that line called? Vertical asymptote, perfect. Number 3, when f is approaching b, as x approaches plus or minus infinity, f is approaching b, then y equal b is a blank blank. Horizontal asymptote, perfect. And for the rational function f of x equal n of x over d of x, if the degree of n of x is exactly one more than the degree of d of x, then the graph has a blank or oblique blank. Check in. Slant. What? Or oblique. What's the second word? Asymptote. Asymptote. All right. Homework exercises, do either 5 or 7. They're both at calcchat.com. 7's at calcview.com. Do any of the odds 9 through 15. They're all at calcchat. 15's at calcview. Do any of the odds 17 to 37. They're all at calcchat. 27's at calcview. I would do all of 39 to 42. However, only 39 and 41 have their answers at calcchat, but you should be able to figure those out. Do either 43 or 45. They're both at calcchat. Do any of the odds 47 to 59. They're all at calcchat. 49 is at calcview. Do either 61 or 63. They're both at calcchat. Now, it says you need a graphing calculator or something like that. If you can't do it without it, don't sweat it, but you should be able, I think, to do it. Oh, wait, those are both slant asymptotes, so don't worry about those, okay? You should be able to do 65 or 67. They're both at calcchat. 69 should be at calcchat. You can do 71. If you don't need graphing calculator, I can't tell just reading it whether you can do it or not. But take a look at it. Average speed is 73. You should be able to do that one. It should be at calcchat. True false, either 75 or 77. They should both be at calcchat. 79 is a think through problem, so you can think about that one. Writing a rational function, 81 or 81, you should think about that. All right, we're not doing 2.7, okay? Now that means we are through with Chapter 2. And for people who came in late, the test on Tuesday will be on Chapter 2. Now, if you want some additional, okay, there's a chapter summary on page 188 and 189. This has a lot of the formula equations and other information. That might be a good place to go for your formula and equation sheet. Remember, you can have one for every test, including the final. So, develop one for Chapter 2. Don't worry about 2.7. We didn't do that. Or slant asymptotes in 2.6. If you need more exercises, there's odd numbers are at calcchat.com and also in the back of the book. 1, any of the odds 3 through 7, and 9, those are off in 2.1. 11, 13 or 15, 17 or 19, and 21, they're all in 2.2, 2.3, 23, 25, and 27. 2.4, 29, either 31 or 33, 35, 37, 39. 2.5, 41, 43, 45, and 47. 2.6, 49, either any of the odds 51 through 57, 59, and that's all you have to do. Okay, if you want to, that's all up to you. The chapter test, again, has all the answers in the back of the book. CalcChat has only the odd numbers, so you can do any of those. I wouldn't mess with 8 or 9 because those have imaginary parts to them. 10 and 11 do too, but 12 and 13 you should be able to do. 14, yeah, you should be able to, okay, except 17 and 18. Those are the inequalities we didn't do. There's problem solving. If you want to take a look at that, you can. Then we get to exponential and logarithmic functions. And since we have, what, about 5 minutes? Okay, let's get as much of that started as possible. Okay. Discard that and get to 3.1. You'll find this is pretty easy stuff, I think, especially the beginning part of it, which is all we're going to get to. So this should be some pretty easy things to do. I'm glad y'all are here, so you get exposed to it. I pity the people who are not here. You guys are going to have to pick it up on their own. But it's not hard to do that either, but it would be helpful to be here, I would hope anyway. So we'll go from current slide. Does anyone know what we mean by an exponential function? Haven't we been using exponents for a while now? Yeah, but they're not exponential functions. Those exponents were all numbers. We're now going to have our exponents being the variables. That's what makes an exponential function. And then the logarithmic functions are going to be the inverse functions of the exponentials, if we get that far. Okay. So exponential function of the graph is 3.1. We'll recognize and evaluate exponential functions with a base of a, any old base. We'll graph exponential function, use the one-to-one property. It's going to be pretty important. We'll recognize, evaluate, and graph exponential function with the base of e. And I don't know if y'all are familiar with e. E is actually the natural base of our whole number system. We say it's base 10, but that's just the counting base. The natural base is e. Trouble with e is it's an irrational number. 2.7, blah, 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 blah. It goes on forever with no pattern. A lot like pi, but different because it's a different number. Then we'll use exponential functions to model and solve some real-life problems. So let's talk about what exponential functions are. So far, this text has dealt mainly with algebraic functions, okay, which includes polynomials and rationals, okay, last chapter, okay. In this chapter, chapter 3, we will study two types of non-algebraic functions. Exponential functions we'll for sure get to. We may not get to logarithmic. Depends on how much time we have next Thursday, a week from today. These functions are examples of what we call transcendental functions, okay. Now, the definition of exponential function, the exponential function f with a base of a, any old number a, is denoted by f of x is equal to a to the x. Now, how does this differ from polynomial function? Polynomial function had the x as the base and the a as the exponent. The number is the exponent, the variable is the base. Exponential functions have a base, a number is the base, and the variable is the exponent. Now, here's a couple of limits that we have on it. A always has to be greater than 0. We do not make our base negative, ever. We don't make our base 0, ever. Because if the base is 0, whatever you raise it to is going to be 0. That's not very interesting. But also, we can't have a equal 1. Because if a was 1, no matter what you raise it to, you still have 1. So those are not very interesting. So we'll have a is greater than 0, not equal to 0, greater than 0, never negative, always positive, but not equal to 1. Okay? X is any real number in the world. Positive, negative, fractions, decimal, rational, irrational, it doesn't matter. They have to be real, though. Okay? Now, the base a is equal to 1 is excluded because it yields f of x equal 1 to the x, which is always 1. Not very much interest there at all. So we leave that one out. Constant function, not an exponential function. You have evaluated a to the x for integer and rational values of x. Those were polynomials, right? For example, you know that 4 to the third power is 64. 4 to the 1/2 power is square root of 4 is 2. Okay? So, you've already done that for rational values of x. The new part will be irrational. However, to evaluate 4 to the x for any real number x, you need to interpret forms with irrational exponents. Now, they go into an awful lot of time fiddling with this, which seems a little unnecessary, but just to give you an idea. What if you had a to the square root of 2? Well, the square root of 2 is an irrational number. It starts off 1.41421356, blah, blah, dot, 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 dot. Never repeats a pattern. Looks like it's going to, but it doesn't. Okay? As a number that gets successfully closer to the approximations, you could start with the first two digits, a to the 1.4. You can do that on your calculator, right? Actually, you can do that on your calculator too. But we'll do that. That should give you a value. Can someone do that real quickly? Do you know how to do this on a calculator? Okay. Find your button or the key on your calculator that looks something like a to the x. Let me get my pen color back. We may be running out of time, are we? Okay. So here's something. Study for the test first, but you can play around with your calculator and see if you can find that key, a to the x or something like this. If you have that key, it's fine. If not, you can do this. Let's say a was 7. Okay, let me get my pen. I thought I had it. Okay, 7 to the 1.4. Okay? You can punch that in. You type in the number 7, and then if you have the caret key, you can do that key and then do 1.4 and hit equal. That's one way to do it. Or if you find that key, type in the first one first, press this key, and then type in the 1.4 and do that. Worry with that later. Fiddle on the test first, and let me see if I can find my pencil. Here we go. And we'll start there next time. Okay, we hardly scratched the surface here today, so we will pick up and go from there on Thursday. Okay, next time we do have the test. Be sure to bring your formula and equation sheets. Be sure to finish your quizzes. If you haven't finished your quizzes, get those into me. Now, if you can't get me your quiz tomorrow, I'll be on the Birmingham campus. If you can get it to me Monday, I'll be here all day, but I have office hours 8 to 10 and 4 to 6, basically. Okay. And if I'm not in my office, you can slide it under my door.